Hello everyone. In this experiment, you will become familiar with the usage of oscilloscopes, function generators, and understand the impact of the AC-DC ground switch on the displayed waveform. Here, we have a digital multimeter, our oscilloscope, a function generator, which creates the patterns of oscillations in the output voltages. And this is our DC power supply. Let me explain briefly how to make our measurements with oscilloscope. To measure voltages for both AC and DC levels, first thing to do is placing the switch in the ground position. This switch here is in the ground position. This will help us to calibrate our device. We need to establish the ground level, which is 0 voltage level on the screen, and this is the vertical sensitivity. Let me power on the oscilloscope. As you see, we can establish our ground level, 0 voltage level on the screen, and here this is vertical sensitivity. Then after that we will place the switch in the AC or DC position here. In order to measure the frequency of the oscillations, we will use the horizontal sensitivity. It's that. We will determine the number of divisions between the peak to peak values of the oscillation on the horizontal axis. Then we will be able to calculate the frequency using the provided horizontal sensitivity. This is our horizontal sensitivity. Okay, let's continue with the procedure of this experiment. In the first part, we will observe the effects of the controls on the oscilloscope. These are focus, intensity, this is vertical position and horizontal position. And notice that there are no connections to the vertical input. Okay, first thing to do is establishing a horizontal line centered on the face of the screen. And here, this is our horizontal line. It should be centered on the screen. Now we are adjusting the focus, and you will note what you observe. Okay. Second is the intensity. And X and Y positions. Here the horizontal position switch. And vertical position, which is Y position. Okay. In the second part, we will measure DC voltage with our oscilloscope. Again, firstly, we need to establish ground zero voltage reference in the Y position. Notice that our switch is in the ground position, and we are establishing our ground zero voltage reference. After that, switch will be in the DC position. We will set the vertical sensitivity to 1 volt per division. Okay. Here we set the vertical sensitivity to 1 volt per division, and we are switching on our power supply. Okay, we are connecting the 1.5 volt output to the one channel of the oscilloscope. Here we can connect this and this. So the vertical shift is about 1.5 squares or 1.5 divisions, but it's not so clear with this sensitivity. Okay, you can calculate the DC voltage by multiplying the vertical shift and vertical sensitivity. Now we are changing the sensitivity to 0.5 per division, 0.5 volt per division. Now the vertical shift is 1, 2, 3 divisions. With these results, you are expected to fill the blanks in your lab manual and answer the questions in your lab manual. Now we will disconnect the voltage source and re-establish the 0 point voltage. Okay, this is we are switching the ground position and we established the 0 volt reference position. This time we will connect the vertical input section of the oscilloscope to the negative lead of the power supply, and the vertical sensitivity is again 1 volt per division. We switch to 1 volt per division and the switch is to the DC position, and we are connecting the positive lead in the negative section and this. As you see, the shift is in the negative direction. From that, you will calculate the DC voltage by multiplying the vertical shift and the vertical sensitivity. Now we are disconnecting our power supply again and we establish the ground 0 voltage position. This time we will connect two power supplies in series. Either of them are 1.5 volts. And the vertical sensitivity is 1 volt per division. And we are switching to DC position. As you see, the vertical shift is about 3 division. When we connect to 1.5 volt batteries in series, the vertical shift is 3 division. Of course, when the sensitivity is 1 volt per division. Now we will measure our output voltage with the digital multimeter that we have here, and positive side in the positive lead, negative side in the negative lead. And as you see, it's 3 volts. Now we are disconnecting our power supply and turning off. You are expected to fill the blanks in the lab manual and answer the questions for this part. In the third part of the experiment, we will learn how to set the magnitude of a sinusoidal wave signal using oscilloscope. The frequency will be fixed at 500 Hz in this part. We are calibrating our oscilloscope again to 0 voltage reference while the switch is in the ground position. The vertical sensitivity is at 1 volt per division, and the horizontal sensitivity is set to 0.5 milliseconds per division. The output frequency of the function generator here is set to 500 Hz. Now we are setting the switch of the oscillator to AC position to capture the sinusoidal waveform. And we are connecting the negative side to negative lead and positive side to positive lead. Now we are adjusting to peak value to 6 volt by changing the amplitude value of the function generator. Okay, as you can see, the peak to peak value is 6 volt here. The mathematical formulation of the resulting waveform is in your lab manuals. It's 3 sine 2 pi 500t. Now we are switching to the DC position on the oscilloscope. Okay. So there is nothing change on the screen. In this part of the experiment, you are expected to sketch both patterns in your lab manual and make the necessary calculations. In the G section on the third part, we need to adjust to sinusoidal wave using the oscilloscope. One of them is 0.2 sine 2 by 500t. So we need to adjust our voltage to 0.2 peak to peak voltage. So the peak to peak voltage should be 0.4. So the sensitivity is 0.1 per division to do that, and we need to adjust our ground position first and switching to AC. Okay, 4 division in the peak to peak value, so it's 0.4 volts peak to peak. In the G section of the third part of the experiment, for the first sine wave, the vertical sensitivity is 0.1 volts per division, and the horizontal sensitivity is 0.5 milliseconds per division. You need to sketch that figure in your lab manuals. For the second sine wave, we need to adjust a 16 volt peak to peak value. So for 16 volt, we adjust our vertical sensitivity to 2 volts per division. So if we go all the way around, 4 to up, 4 to down, it's 16 volt peak to peak value. So for the second sine wave, 8 sine 2 pi 500t, the vertical sensitivity is 2 volts per division, and the horizontal sensitivity is 0.5 milliseconds per division. You need to sketch that figure also. Now we will connect the digital multimeter directly to the function generator or oscillator in the AC RMS mode, and we will adjust the oscillator output to 2.12 volts. Okay, I am disconnecting the function generator, and here is our multimeter in the AC RMS mode. And we connect it. Now we need to adjust the output voltage to 2.12. Okay, this is the effective value of the first sine wave that we adjusted. So it is the 3 sine 2 pi 500t. Okay. We are adjusting one more time. Now we will connect this function to the oscilloscope in order to see the pattern again. And 1 volt per division for the vertical sensitivity. It's in the AC mode. As you can see that again the peak to peak value is 6 volt, as we adjusted before. In the ith section of the third part of the experiment, we need to adjust another sinusoidal wave, 0.5 sine 2 pi 500t, and its effective value can be calculated as 0.35. So again, we will connect our function generator to the multimeter in the AC RMS mode. And we will adjust it to 0.35. Now we will connect it to the oscilloscope. Okay, we will adjust our vertical sensitivity. From that we can calculate the peak to peak voltage value. So vertical sensitivity here is 0.5 volts per division, and there are 2 divisions between the 2 peak values. So 0.5 multiplied by 2 is 1. This is the end of the third part. We will continue with the fourth part of the experiment. In the fourth part, we will observe how the oscilloscope can be used to set frequency output of a function generator. For an example, we consider a waveform 2 sine 2 pi 500t. Here the frequency is 500 Hz and period is 2 milliseconds by dividing 1 over 500. If the horizontal sensitivity is 0.5 millisecond per division, the waveform should appear in 4 horizontal divisions. Here, as you can see, 1, 2, 3, 4, and our horizontal sensitivity is 0.5 division, and the frequency of the function generator is 500 Hz, and as you can see, the number of divisions from peak to peak is 4, while our vertical sensitivity is 0.5 division. So this is for a waveform as to sine 2 pi 500t. Now we will adjust two waveforms given in the lab manual. First one is 0.4 sine 62.832t. Here the frequency is 10 Hz, which can be found directly dividing the variable of the sine function by 2 pi. It's 10 Hz. And the period is 1 over 10 equals 0.1 second. Okay, we can adjust our function generator's frequency to 10 Hz. And we can adjust our horizontal sensitivity. The period was 0.1 second. And here we adjusted our horizontal sensitivity to 10 millisecond per division. And our vertical sensitivity is adjusted to 0.1 volts per division, so we can get 0.4. Okay, we adjusted our vertical sensitivity to 0.2, so we can get 0.8 peak to peak value. And horizontal, we can adjust our horizontal position to see the wave more clearly. Okay, here you are expected to sketch the figure and fill in the blanks in the lab manual. For the second function, we need to adjust a waveform like 5 sine 377t. Here the frequency is 60 Hz and the period is 1 over 60 equals approximately 0.02 seconds. Okay, we are adjusting the function generator's frequency to 60 Hz. And horizontal sensitivity to 2 milliseconds, so that we can see the wave clearly. Or we can adjust it to 5 milliseconds. It is seen more clearly like that. And we need to get a 10 volt peak to peak value. So I'm adjusting the vertical sensitivity to 5 volts per division. So you can see that this is 10 volts per division. So our waveform is like that. The horizontal sensitivity is 5 milliseconds per division and the vertical sensitivity is 5 volts per division. This is for the second waveform. Again, you are expected to sketch the figure and fill in the blanks in the lab menu. In the fifth part, we will observe how the AC and DC switches affect the waveform appearing on the screen. The waveform is given as 1 sine 2 pi 500t. Here the frequency is 500 Hz. The vertical sensitivity is 1 volt per division. And the horizontal sensitivity is 0.5 milliseconds per division. So we establish our ground position. Now I'm switching to AC position. And we are adjusting our wave to 1 sine 2 pi 500t. So it should have 2 volts peak to peak volume. Now we have our waveform. We will connect a 1.5 volt power supply to the function generator in series. So our power supply is 1.5 volts. We are connecting the plus lead of the function generator to negative lead of the power supply, and the plus lead of the power supply is connected to the oscillator. Okay. Now we are checking our ground position on the screen, and it's 0 volt reference again. Now we are switching to the AC mode. Observe the pattern in the screen, and you are again expected to sketch the figure on the lab manual. Now the switch is set to DC mode. And sketch that figure also. Notice the changes in the pattern or the location of the waveform, and answer the question in the lab manual. Now we are switching to the ground position, and as you expect, there is a line in the 0 volt reference point. This was the last part of the experiment. You are expected to fill all the blanks and answer all the questions. After that, answer the problems in the lab manual.